So good morning, everyone. I just want to cover a few things with you this morning for your project and for your drawing project, and also for your report for the project of Halloween. So for the report for the project Halloween, you're going to have to do a drawing of your circuitry. So when you search for parts, let's look a little bit at the parts that you will need for the little project for the drawing. So the NE 555, and you get right away single NE procedure timer, and you can just double click it and it's perfect. Then you will need a 4017, and you have a few of them here. A lot of them are different. We're just going to take the first one. JSON decade counter with 10 decoded outputs. And just a few things so you see here that are important to notice are the schematic model here is shown. Also the footprint for when you're going to do PCB design is also here. But that you will learn a little later on next year. But I just thought I'd show it to you. That's in this software. Next year, you'll be using a different software. One thing you want to keep in mind to look at if you want to simulate is to keep a watch over here. I remember that I saw that some of these do not have a model, no simulation model. So if the part you actually needed was this one, unfortunately, your simulation will not work. So your circuit will not work in Proteus. So we take the first one, we double click on it, and then it appears right here in the corner underneath. What else do we need? We need a connector. Oh, I said, okay, I shouldn't close that. So I reopen it. And for the connectors, we have quite a few of them in Proteus, but we're gonna just look for CONN connectors. We're going to click on connectors. They should show up. Okay. Give me a second. Let me find them. So you see, you have many connectors. You have over 3,000 connectors. So we're going to go to a subcategory. And there's a DIL, which is a dual inline connector. That means there's 2 rows of connectors side by side. That's not what we want. We want just a single, so it's SIL, single inline connector. And you have a whole bunch of them. You have here a 2 connector. That's what we need for this project. You'll see, I'll show you the Arduino ones afterwards. The Arduinos are a little bit different. We do have Arduino connectors, but let's just go with the SIL first, because that's what you need for the first project. What else do we need for for this project? We need the capacitors. So your capacitor, if you look at your drawing, C1 and C3 are polarized capacitors. So if we look for a capacitor, and that's the generic. We should get more of these. Also, manufacturers. So with the cap, we're only getting 1 capacitor, but I know there's a lot of them. So I'm going to erase here. I'm going to get everything. And I'm going to take capacitors. There's too many. There's 7,000 of them. There's animated capacitors. There's all sorts of different kinds of capacitors. The ones we're going to take the generic for today. We're going to take the cap. And the cap And this is the real capacitor model. Generic. And I want the active one. Non-polarized. There's a lot of them. So as you see, you have a lot of capacitors. We're going to take these two that I've selected, the cap and the cap pole right here. And then we're going to do the next search. For the resistors, we need a normal resistor. And we can just take the generic resistor symbol. And we also need a potentiometer. So R11, if you look at your drawing, is a potentiometer. So for that one, I actually know the name of it. But if I take resistor off here, I'm going to try. Let's see. I know it's called a pot-HG. So let me try pot. See if we find it. So we know we only want resistors. Oh, I think it's right here. It has been selected. Yeah, it's the pot here is good, but we want the active one that we're actually going to be able to select directly into our drawing, and we're going to be able to change while the simulation is going on. So we're going to choose this one. Okay, so this is probably not everything you need, but almost everything you need. Oh, the LEDs. Yes, you need some LEDs. And we do want the active ones. So they are, if we go down, we see that we have a whole bunch of active ones. The active ones means that you're actually going to see when they light up and you're going to see when they shut off. So I don't know, any color you want. I'm going to choose the green one. Double click on it. What else do we need? Resistors. VCC and ground. Okay. So, oh yeah, you don't want to press there. The N555, NE555, and the 47. I'm going to put them about the same as the drawing. What I want you to do is make it neat. You might not have enough space here to do it exactly like it is in the drawing that you're starting from, but you want to make it neat and very comprehensive. When we look at the grounds, they're right here, terminal. We want to take the ground and just click on it and put it. The thing you want to do is you want to put your parts first and then wire. Because if you put your wires and then you want to put a part on it, you're going to have to break the wire, put it in. Depending on the version you're using, some of the versions actually don't let you do that. And we want power. And the power looks a little bit different than, than it does on the drawing, but that's okay. You put it up here. Once you've put it on, you want to double click it and actually say +5 volts. Remember one rule of thumb, all your power are towards the top. All your grounds must be facing downwards. I don't want to see a ground, even though maybe you had to, for pin 3, you had to put a ground. I don't want to see a wire going upwards and a ground going upwards. Grounds are always downwards. So find a way to put it downwards if that's the case. Okay, so I'm going to stop sharing. Give me a second. I'm going to stop sharing this file, and I'm going to share the drawing in a second. So one of the things I wanted to bring your attention to is which wires are connected with each other and which wires aren't. What you want to look at is, if I zoom in, is this dot over here. This little dot over here or over here, they're all over the place, means that the wires are connected together. When you have a wire here going through and you see no dot, by the way, I would like you to try to find a different solution than having your wire go right underneath a resistance. You want to space it out a little bit so you don't get this confusion. Right now, there's a confusion. Is this wire connected here or not? So to take away the confusion, you want to pull this resistor higher up so it doesn't come in contact with the wire. But if it is connected, it should have a dot. If it's not connected, it should not have a dot. Okay. So one last thing I want to cover before I let you work on your project by yourself. You can ask me questions. I'm here in class with you. Is the connectors for Arduino. And that's the ones that you're going to have to use for the report for your Halloween project, which is fairly a big report. So I'm going to ask you to take your time and do it. So we're going for the connectors. Okay, I'm not getting connectors right here. Connectors and type, I want Arduino connectors. And there's a few different kinds. So you'll have here and these. And let's look at these. They're actually different things. I2C, matrix. So what we want to concentrate on is here, the SIL 10, SIL 6, SIL 8. And if you take your Arduino and you look at your Arduino, you will see that that's exactly what you have for your Arduino. So I'm taking out an Arduino right now. And the connectors right here, if you check what they are going to be a 6. 2 of them are SIL 8, and 1 of them is a SIL 10. Okay, so all 3 of these, SIL 10, SIL 6, SIL 8, are things that you need for the project, for the report for the Halloween project. So we have here, if we take SIL 6, so we have it there. By the way, in the last video, I was on a laptop that didn't have a plus sign dedicated. Here I have, so I can press plus and I can rotate it before I deposit it on my drawing. Let's say I want it like this. So this will be, let's say, the digital pins from 0 to 7. So this is the 6. So the 6 is A0 to A5. So I'm going to rotate it because this is how you find it. Press enter. And here you have them. SIL 8. I'm going to put 1 over here because that's what it looks like. Let me remove what I had above. I don't need these for now. Another sill 8 is over here, but it's facing the other way. Well, at least in my eyes, it's facing the other way. So I want to align it with this one. It looks about right. And then the sill 10 is above here. And these pins are actually pin 8 to 13, ground, reference, and 2 more pins that you don't see what they are. Okay, so with this, I think you're ready for today and to do your project. If you have any questions, I'm right here.